In this lesson, we're going to talk about the hardware needed for various Ops Manager components. The first component is the Ops Manager application server, which when the Ops Manager package is installed, has a web server and a backup daemon. Any server that is running the Ops Manager package will require 15 gigabytes of RAM dedicated to Ops Manager and at least 4 cores of a modern CPU. These 4 cores will support up to 400 MongoD and MongoS processes that are being monitored and managed by the Ops Manager service. For more than 400 hosts, up to 2,000 hosts, 8 cores are recommended. If you want to stay with this 4-core number, or you're actually going to be running more than 2,000 MongoD and MongoS processes in your deployment, it is recommended that you run multiple Ops Manager application servers and place those servers behind a load balancer. This will allow you to add servers as necessary and increase your scale. The next component is the Ops Manager application database. It is recommended that you have at least 200 gigabytes of storage in this database. The storage can be either fast spinning disks, meaning 10K drives, or it could be SSDs. If you're going to be monitoring and managing up to 400 hosts, it is recommended that you have 8 gigabytes of RAM available for this Mongo process. For more than 400 hosts, up to 2,000 hosts, it is recommended that you have 16 gigabytes of RAM available. If you're going to be using more than 2,000 hosts, you could solve this problem by running a MongoDB sharded cluster. The next component to talk about sizing is the backup daemon. RAM and CPU were taken care of when we talked about the Ops Manager package earlier, but if you're running an atypical workload, let's say your source replica set or sharded cluster has a rather large working set, it's possible that the backup daemon will need more RAM and CPU to be able to keep up with that backup. Disk space is particularly important when sizing the head directory. If you're backing up a source dataset with 1 terabyte of data, the head directory will need at least 1 terabyte of space as well. It is recommended that you have at least 10 to 20% extra space to handle these data directory growing or temporary files that are needed. If you want to support point-in-time restores of this 1 terabyte backup, you will need an additional 1 terabyte of disk space in this head directory. That is because to accomplish a point-in-time restore, the backup daemon will take a snapshot out of snapshot storage, place it temporarily on disk in the head directory, and apply op logs from the point that snapshot was taken to the time that was requested in the point-in-time restore. So during that process, there will actually be 2 full copies of the data on disk. For larger deployments, backing up many replica sets, it is recommended that you set up a dedicated restore daemon. In this example, we have 2 daemons, each with 4 1 terabyte backups. That means in total on each server, we have 4 terabytes of disk space. If we wanted to support point-in-time restores with these 2 servers, we would need an additional 4 terabytes of disk space on each server. This means we have a total of 16 terabytes needed. The advantage of this is all 8 of these replica sets can have a point-in-time restore going at the same time. But we are actually wasting this 8 terabytes of space most of the time whenever a restore is not happening. To reduce the amount of waste, we can bring up another backup daemon. On these first 2 backup daemons, set them to not do restore jobs, and this third backup daemon could exclusively do restore jobs. In this third backup daemon, we will put 4 terabytes of space. So this means that whenever a point-in-time restore is requested, it will go to this third backup daemon, where we have enough capacity to do 4 point-in-time restores at a time. This is less than the capacity of 8 before, but now you'll notice we only need 12 terabytes of disk space rather than having the 16 and wasting this extra 4. Next, we'll talk about sizing of snapshot storage. There are 2 types of storage, file system and block store. We'll begin by talking about the file system. There are 3 things you need to know to decide how big your file system storage is going to be. First is the original file size of any replica set that's being backed up. Next, you need the compression ratio, that is how compressible that data is. If you are running WiredTiger, the files on disk are likely already compressed, so your original file size actually already contains the compression ratio. If you are running Mmap, you will need to sample your data directory and compress it to see what your compression ratio is. The next thing is you take those 2 numbers and multiply by the number of snapshots that you will be storing at steady state. The default snapshot schedule for Ops Manager is to take one every 6 hours and store it for 48 hours, once a day, store it for a week, once a week, store it for a month, and once a month and store it for a year. After a year, at steady state, the default schedule will give you 27 snapshots. So again, multiplying your file size by the compression ratio by 27, if you have not modified the default schedule, will give you the amount of space a backup will take up in snapshot storage on a file system. Moving over to Block Store, we have the same first three numbers, the original file size, compression ratio, and number of snapshots. The real variable here is a deduplication ratio, since the Block Store will do native deduplication. If you have an insert-only workload, you will get great deduplication. If you have a workload where your entire database changes every time it's time to take a snapshot, you will get bad deduplication, and your overall storage in the Block Store will look closer to what you get on the file system. A good rule of thumb for determining how large the Block Store will be for typical workloads is 2 to 3 times the original data size. For more complicated workloads, the support team has built a calculator that will help estimate Block Store size. The last component to size is oplog storage. There are 3 components that go into deciding how much oplog storage you will need: the amount of oplog generated per day by your source replica set, how well that oplog compresses, and how many days you want the server to store oplogs. This last component is configurable in Ops Manager and determines how many days you'll be able to go back to do a point-in-time restore.